We are Burckhardt Compression, and I'd like to start with a short overview about our company. We are about reciprocating compressors. It's a company running here in Switzerland for more than 175 years. We produce almost 500 compressors per year. And you see our machines, for example, if you are a refinery, if you work in a refinery, you see this compressor in the left side as normally a make-up compressor for hydrogen in hydrocracking, hydrotreating plants. This compressor is also used in the LDPE business, in low-density polyethylene as a booster primer or purge primer compressor with the pressure going up to 250 bar. And then you have this compressor in the right side, the hyper compressor or secondary compressor in the LDPE business. This one is an amazing machine. It goes up to 3,500 bar in some applications, and it's necessary, to produce the LDPE. Last but not least, also very important for PP and high-density polyethylene business is the labyrinth compressor that you see more in the right top. This is a compressor that we recommend for not only the plastic production, but also for some industrial gas application, and also for the marine business, gas transportation. This is most part of our portfolio. We are always developing new products, and I believe you have a better view about this portfolio during our presentation. The content here, we have 3 topics to cover. Capacity increase, so we are talking about the bottlenecking and also reliability. We are going to show you an example in PP plants with the lab compressor. Maintenance is also an important topic. It's always important topic. So we are going to tell you about our involvement in the LDPE maintenance turnaround of our compression train, and also about the data collection and analyze our digital initiatives will be presented by Mr. Draxler. We have, as a compressor OEM, some challenges in the production of plastics, especially PP and high-density polyethylene. 2 main challenges for PP, for example, contamination with TEL and catalysts, and also the solubility of the oil with process gas. These topics, they must be carefully taken care during the design phase in the compressor selection, during plant implementation, because otherwise you have frequent stops due to contamination and problem with our oil that's lubricating your compressor bearings and crankshaft, connection rod, and so on. For example, when you open the compressor, this is the consequence of the tail, for example. You can see powder here in the compressor components, and if your compressor is not properly sized, is not properly selected, you have many stops to clean the whole thing, go for maintenance, replace parts, and so on. And of course, this downtime means you are losing money, your plant is not able to produce. So to overcome this issue, this first issue, the contamination, we offer for our customers the labyrinth compressor, our lab compressor. It's a vertical machine. You have here a crankshaft moving the connecting rod crosshead system, as you know, for any compressor. And in the cylinder area, in the gas compression area, we have a piston that is not lubricated. This is one important characteristic for our customer. It's not lubricated, but it's also different from the compressors that I mentioned in the beginning that are applied, for example, in refineries, because we do not have sealing rings. The sealing rings you see in the central picture in the left side, they are not present in the lab. Instead, the sealing effect is given by a vortex because there is a different profile between the piston itself and the cylinder wall. So there is no contact between these mechanical parts. There is therefore no friction, and even without oil, non-lubricated applications here in the cylinder chamber, we have an excellent lifetime. Many plants operating for more than 2 years, and our experience says that if you had a ring piston, we would be able to operate perhaps 6 to 8 months because you would constantly have to replace the sealing elements. So now about our case, one customer approached us to evaluate how they could increase capacity around 10% for a PP plant producing circa 300 kilotons per year. So the first step is a feasibility study. We check all the parameters that are important for compressor operation, so process condition, what's exactly size of the compressor that you need for this customer request, which loads you have in the compressor, shaft power, foundation, and also the cooling that's necessary, interstage, size of dampers due to pulsation, vibration, and so on. So to give you an overview about what is calculated in such feasibility studies, let's say you have the bottleneck of your plant is now your reciprocating compressor. What we evaluate in such feasibility studies. So, for example, what's the influence of the new suction pressure in the shaft power? What will be the new pulsation vibrations after you run your plant with these new parameters? And also, for this specific case here, we realized that it was necessary to replace the coupling. So we made an evaluation for torsional analysis of the complete shaft train. So the motor, the coupling, the flywheel, and also the compressor crankshaft to make sure the new loads would not be a problem for our original shaft train. From the feasibility study, we realized, yeah, that's possible. It's really not a problem for us to go ahead with this project. We just need new cylinders because we need more space in the cylinder area to accommodate the additional gas. New coupling, as I said, and you can remain with the original auxiliaries, foundation, coolers, dampers, and so on. So the study was approved, the project went ahead. We started with the plant and compressor engineering. So what has to be adjusted in the plant? We did everything firstly in our electronic model. And then we start with the production of the parts. So here you can see new cylinders being produced, pressure test in Switzerland. And then we went to the site for removal of existing cylinders and installation of the new ones, supporting customer with our field service supervision team. Another important topic here is that since there is no direct contact in the ceiling here in the compressor chamber, some gas they can get in contact with the lubrication oil, and in this case we create a barrier here to overcome this problem because we inject fresh process gas here, fresh propylene, to create a barrier and avoid that the process gas that you can see in the blue arrow here goes in contact with the lubrication system. If the system is not properly sized, we experimented in the past, years in the past, that the pressure in this distance piece, the zone between the cylinder and the crankcase, will go up, and then the customer has to release. If you see in the right side, the light blue trend, the pressure is going up and the customer has to release this pressure to flare. What we did, we recalculated the pressure control system of this gas that's injected here, and we resized the lines to give the customer a better path flow of this gas that were then collected and sent back to compressor suction. So the outcome was a stable pressure control after the implementations, and even the customer was surprised with this outcome. You see some internal memorandums from customer saying, above my expectations, the stuffing box, it means the piston rod gland is still stable, and 120 days later, the flaring reduction initiative results up to data are extremely promising. So customer very satisfied with the implementations made by Burckhardt Compression. This is our first case. I will shortly give you an overview about our involvement in the maintenance business, especially our services division. We have now we took over some turnaround maintenance projects, especially for LDPE plants, because we have two huge compressors. As I said, some of these machines, they go up to 3,500 bar, and motor power can be higher than 25 megawatts, so impressive machines. You see one of them, the left side, being assembled in our factory, and one installed in one of our customers. We have complete program to define scope. It can be compressor inspection, but nowadays we use mostly data from the monitoring system. We can also go to customer to do complete vibration measurement. We discuss with process engineers, operations team, how the plant will be operated in the next years to define if the capacity, the size of the compressor must be adjusted, and then this additional scope is also implemented in the maintenance program, and it's part of our schedule. And in the end, we defined a planning, you know, as you always do for your turnaround, and we execute this planning many times in turnkey basis. So the customer, they really do not have to work with the compressors during the intervention because they will be under our coordination. We had this experience in the past, you know, have some case that we could share with customers. And I also brought here a quote from one of our customers, really satisfied with the level of service performed by Burckhardt Compression, and important also for you to conclude this project on time in our LDP plant. So this is also important for all customers, for everybody involved in the petrochemical and refinery business, and it's also our commitment. I would like now to thank you for your attention. I would like to say I'm open for the questions, of course, and it's my pleasure to introduce my colleague, Mr. Helmut Draxler, that will go ahead with our presentation. Thank you very much.
Thank you.
Then I'd like also to welcome everybody, and I was asked to give you a snapshot on our digital activities, what we are doing there. As said, it's a brief update. Presentation is available afterwards, and also an invitation to have following up discussions on the topic. Well, digitalization is in everybody's mouth, and it's a big thing. And what are we doing? We had a very intensive sessions with our customers and had interviews with them, and the outcome was very much clear. They are striving towards tangible improvements in costs and performance. That's what they want to achieve. They expect increased uptime and decreased costs enabled through digitalization. So, and the third one is they expect us to deliver something which is on one side a compliment, but on the other side also a clear expectation. What is also clear on the market, there's a shortage on skilled on-site technicians. That's what we are facing. And that means we have to come with alternative solutions. And there's a complex company-wide IT infrastructure usually in place, especially with the supersized companies. And what is also a point is sustainability, safety, and efficiency drive the digital agenda of quite some companies we're in touch with. So what we did is we had a look at the improvements alongside the customer value chain. Where can we help to improve? And the red ones are marked. It always goes about improved on-site knowledge, decreased downtime, minimize downtime, decrease downtime, optimize maintenance, and guaranteed availability. So I think the mission is clear, and that's what we are working on. When you look at what we've done so far, on the left side, the technical engineering of the compressor, we brought the physics always to the limits and are working on that topic since 175 years. But also on the right side, you can further optimize the operations by using data in a smart way. And how do we do that? The enabling platform is the digital twin in the middle. So what we have in the data should reflect the reality as close as possible and as much as possible. What do we have on the left side? Thiago mentioned already, we have proven technology, we have continuous improvements, and we have a life cycle documentation. But on the right side, we do status monitoring, we do condition-based monitoring, we started prediction-based initiatives. I will show you something there, and also life cycle documentation. What is the target? Is fast and early reaction on deviations, planned or unplanned, to increase the availability. We have built our solution offering. We will bring it to the market under the label UP Solutions. The name already says what it stands for. It includes a digital training academy and remote guidance and consulting. So this goes from remote support towards training, towards guided instructions. Then we have the predictive maintenance in the middle, where we talk about connected compressor and spare parts. So the compressor is connected, and based on the data, we can see how is the machine doing, and we can also predict a certain necessity for action. And we have a solutions configurator offering where we want to be an easy to deal with partner and to bring all the information towards the customer in one solution, so you don't have to interface with many applications, and we connect either in your application set, or we offer even a MyFleet portal for the customers. So I give you some experiences here shared with you. It's not on PowerPoint only. So what we do is we have quite an intensive cooperation with some early stage customers. We call them MVP customers, minimum viable product customers. We have done training during the COVID-19 travel ban. We were also forced, like others, to reorganize ourselves. Thankfully, we have been starting exploring the topic already in 2019. So we have enabled our service engineers with some trainings they can do. We also give them partially, where possible and needed, to customers engineers if they have to do the job. Then we did some trainings execution with one customer who is interested in a plant. We have installed a remote assist solution on a LNG tanker, Flex Rainbow, and we did the remote support exercise whilst they have been under heavy thunderstorm via satellite link, which was quite amazing experience. And we have other MVP customers who will join our journey here. What we've done, we have connected compressors in the test bed. This is, for example, a new marine compressor, and we have collected all this data and make them available on one side in a monitoring solution, but also in machine learning algorithms. And here we have one, for example, H2 compressor, means that's an ATEX application. And also here, the same solution, the same data that can be gathered and can be fed into algorithms for maintenance prediction. What is the target of all? I mean, I think I don't have to tell you that the corrective maintenance, that means the error happens and then people are in a panic, and then parts are ordered and the field service engineers are sent out. This is not what is the target of everybody, and this is also quite outdated nowadays. Many companies offer preventive maintenance. That's also what we did. And that means we overhaul, we plan certain repairs, overhaul work. But again, the question is it really needed, or could the machine run even longer? Where we are in today, state of the art is more or less the condition-based maintenance, where you detect a certain condition, and based on that detection, the work is then planned and scheduled. The only disadvantage here with the condition-based maintenance, it's still quite late. That means you must do something, you must intervene. And what the target is now with this predictive maintenance, we try to predict the healthiness status of the compressor, let's say it in this way, and from the conditions we monitor to predict what is the remaining time the machine will run, and based on this remaining time we can plan the overhaul work. Target is clearly the uptime extension, so the machine should run longer and should be repaired as late as possible, but there should not be an unplanned outage. This is what the customers tell us. The highest cost in the total cost of ownership is not the spare parts and the service engineer, it's the outage of the machine that cannot work and create revenues and profits. So what we do here, we have started some activities, for example, remote support and digital trainings. This is for very fast knowledge transfer wherever possible. Again, this was installed on the first vessel, others to come now. And we have also started preparing some digital trainings or in discussion with the customer on his request to see where we can enable digital training material that the customers can train themselves, for example. And the compressor, connected compressor and data analytics, we have started creating a shared digital twin, which is fed and updated by both parties, means us as a supplier, but also the customer. So when the customer is changing, for example, a valve, We usually have not we don't have this fact in our documentation, and also the other way around. So this is something we are creating now. Then we have an initiated joint data analytics workshop we have done on the topic predicting incidents and the extent the uptime of the compressor. Here we have also a marine partner, which brings another complexity of a vessel that is moving and has some special conditions like waves, etc., that may impact a model as well. And what is also topic is the optimization of the gas consumption or gas losses. And this is what I mentioned in the first slide. This has also an impact on sustainability topics. The less intervention is needed on the machine, the less gas emission is there. So that's also something what we are working on. Well, this is what we do together in a co-creation approach. It shows clearly that the combination of the operations knowledge of the customer combined with our OEM knowledge is the best fit and the best outcome for prediction models. For example, the customers have the operations knowledge. We have it from testbed, but that's not really operations knowledge. But we have the engineering knowledge and can identify the root causes. So whenever somebody is interested, getting in touch, here's my email address, and then we could do some follow-ups later then. So that's from my side, very quickly guiding that through the exercise we are doing in the digital services to further extend maintenance cycles and increase the uptime of the machine. Thank you.